The periscope lens revealed something that would fundamentally alter every strategic assumption held by the Imperial Japanese Naval General Staff. Lieutenant Commander Takeshi Matsumura, positioned carefully aboard the submarine I-36, methodically scanned the American anchorage spread before him. His training had prepared him for many scenarios, but nothing could have readied him for what now filled his vision. The waters of the lagoon contained not merely a collection of warships at anchor, but something that resembled an entire manufacturing complex somehow transported to float upon the ocean itself. Inside his uniform, pressed against his chest, a small notebook waited to receive observations that would eventually send tremors through the upper echelons of Japanese military command. His methodical count through the optical instrument identified 6 enormous floating platforms, each one exceeding in dimensions any dry dock facility that existed anywhere within the Japanese home islands. On one of these massive structures, the battleship USS Alabama sat completely elevated above the waterline, its massive hull exposed to the air and covered with swarms of labourers and their equipment. Another platform held not 1 but 2 cruisers at the same time. The implications struck Matsumura with the force of a depth charge. The Americans had done something the Japanese naval planners had considered impossible. They had transported their shipbuilding and repair infrastructure directly to the combat zone. That evening, as Matsumura composed his encrypted transmission back to headquarters, he chose words that would echo through subsequent Japanese strategic discussions with ominous resonance. Their capacity to restore damaged vessels to operational status exceeds the rate at which our kamikaze pilots can inflict harm upon them. This conflict has ceased to be a conventional naval engagement. We are confronting an arithmetic problem that our resources cannot solve. The enormous structures that had captured Matsumura's shocked attention belonged to the Auxiliary Floating Dry Dock series, known by the designation AFDB. Each section of these remarkable constructions had been manufactured at separate American shipyards scattered across the country, then towed thousands of miles across the Pacific Ocean to be joined together like pieces of an immense steel jigsaw puzzle. The second unit in this series, AFDB-2, measured 927 feet in length and possessed the capability to lift 90,000 tons clear of the water. Operating at full capacity with its complement of 600 personnel, this single floating facility contained complete machine shops, foundry operations, electrical repair workshops, and storage tanks holding 65,000 gallons of fuel oil. The dock generated its own electrical power, produced its own fresh water through distillation, and functioned with the organizational efficiency of a major shore-based naval shipyard. What Lieutenant Commander Matsumura's periscope observation could not reveal would have shattered Japanese naval doctrine even more completely. Distributed throughout the Pacific Theatre, 7 major advanced base sectional docks and 31 smaller auxiliary floating docks were systematically transforming every captured coral atoll into something approximating the capability of Pearl Harbor itself. 3 weeks before the attack on Pearl Harbor, in the conference chambers where the Japanese Naval General Staff conducted their planning in Tokyo, Vice Admiral Osami Nagano had laid out the final war plans for review. The calculations had appeared thoroughly sound and well-reasoned. American industrial capacity included 8 significant naval shipyards positioned along the Pacific coastline. The facility at Mare Island in California possessed the capability to handle 4 capital ships simultaneously undergoing major work. The Puget Sound Naval Shipyard, located in Washington state, could accommodate 3 such vessels. Pearl Harbor's facilities, being the closest to what would become the war zone, might manage perhaps 6 major repair operations concurrently. The mathematical projections had seemed favorable to Japanese planners. If Japanese military forces could succeed in damaging or sinking 20 American capital ships during the initial 6 months of conflict, conventional wisdom suggested the Americans would require at least 18 months to complete repairs and replacement construction. Damaged vessels would face a journey of 3,000 miles back to the Pacific coast facilities. The voyage alone consumed 2 weeks in each direction, effectively removing ships from active combat status for months at a time. Admiral Isoroku Yamamoto, despite harboring significant reservations about initiating hostilities with the United States, had approved these estimates as reasonable. His operations officer, Commander Kameto Kuroshima, had prepared detailed charts analyzing American industrial capacity. The United States had produced 1.5 million tons of merchant shipping during 1941. Japan had produced 400,000 tons during the same period. However, Kuroshima had argued that naval construction represented a fundamentally different challenge. Warships demanded specialized facilities, workers with particular skills, and specific materials. The limiting factor would prove to be available dock space and repair infrastructure, not raw industrial power. None of them had imagined that the Americans would simply construct new shipyards and transport them by sea directly to the battle zones. The historical origins of American floating dry dock technology actually traced back to commercial requirements. In 1927, the United States Navy had commissioned its first self-docking floating dry dock, designated YFD-2. Unlike permanent dry docks carved from granite and reinforced concrete, floating dry docks operated on fundamental ballast principles. Pumping water from their tanks caused them to rise. Flooding those same tanks caused them to sink beneath the surface. A damaged ship could position itself over a submerged dock, which would then be raised to lift the vessel completely free of the water. By 1940, naval strategic planners had recognized that this technology, dramatically scaled up and made genuinely mobile, could effectively eliminate geography as a limiting constraint in naval warfare. The Bureau of Ships initiated an ambitious program that seemed to challenge the boundaries of possibility even for American engineers. The goals were audacious: construct floating dry docks of sufficient size to accommodate battleships, design them as sectional units for ocean transport, and engineer them to operate independently in remote locations without shore support. The Advanced Base Sectional Dock Program exemplified American industrial organization operating at its most ambitious scale. Section A would undergo construction at Everett Pacific Shipbuilding, located in Washington. Sections B and C would be built at Chicago Bridge and Iron facilities in California. Sections D through G would be manufactured at Mare Island Naval Shipyard. Each individual section weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth. 10 sections assembled together would create a floating dock capable of lifting an Iowa-class battleship entirely out of the ocean. The engineering obstacles appeared nearly insurmountable. Each section needed sufficient structural strength to survive Pacific storm conditions during lengthy ocean towing operations, yet required precision machining to permit welding to adjacent sections with tolerances measured in millimeters. The ballast control systems had to operate in perfect synchronization across all sections. The docks required fully equipped machine shops capable of manufacturing any replacement component, from propeller shafts to major gun barrels. Commander Tamachi Hara, commanding the destroyer Shigur, witnessed American repair capabilities directly when his vessel engaged United States forces near Tulagi during March 1943. In memoirs composed after the war's conclusion, he described the bewildering experience. Japanese forces had successfully struck the cruiser USS Helena with torpedo damage. Intelligence assessments predicted the vessel would require 6 months in a stationary dry dock facility. Yet 3 weeks following the attack, the Helena appeared in Japanese reconnaissance photographs at Tulagi, fully operational and firing her main batteries at Japanese aircraft. The situation defied comprehension. Where had the dry dock come from? Japanese observers saw only empty ocean and small coral islands. The Helena had actually undergone repairs at ABSD-1, which had been assembled at Espiritu Santo only weeks earlier. The dock had lifted the 10,000-ton cruiser completely clear of the water, repaired the 20-foot gash torn in her hull plating, and returned her to active service within 19 days. The identical repair work at Yokosuka Naval Arsenal would have consumed 4 months minimum. Captain Hara's confusion reflected a fundamental misunderstanding that continued to plague Japanese naval planning throughout the conflict. Japanese strategic thinking conceived of naval bases as permanent installations with facilities constructed over decades. Yokosuka Naval Arsenal, Japan's premier facility, had been under continuous construction and expansion since 1866. The Americans had somehow created equivalent capability within 6 months and transported it directly to forward operating areas. Admiral Chester Nimitz grasped that floating dry docks fundamentally transformed the mathematics of attrition warfare. In a memorandum addressed to Admiral Ernest King and dated January 15, 1943, Nimitz articulated this understanding clearly. The presence of floating dry dock facilities in forward operational areas fundamentally alters the correlation of forces at our disposal. A damaged vessel repaired within 3 weeks at Ulithi rather than 3 months at San Francisco represents a 4-fold multiplication in available force strength. The Japanese High Command discovered this new strategic reality gradually and with growing alarm. The Battle of Santa Cruz in October 1942 had inflicted severe damage on the aircraft carrier USS Enterprise. Japanese naval intelligence made confident estimates of 6 months required for comprehensive repairs. The Enterprise reappeared in combat operations after merely 30 days, having undergone repairs at New Caledonia, utilizing the destroyer tender USS Vestal and advance base facilities. Rear Admiral Matome Ugaki recorded in his personal diary an observation that captured growing Japanese bewilderment. The enemy's repair and restoration capabilities exceed our intelligence estimates by factors we cannot adequately explain. Vessels we confirm as severely damaged return to active combat before our own lightly damaged ships complete basic repairs. By early 1943, the United States Navy had established and operated a comprehensive network of floating repair facilities that transformed Pacific Ocean operations. Advanced base sectional docks maintained operations at Espiritu Santo, Ulithi, Leyte Gulf, and Manus. Smaller floating dry docks serviced destroyers and submarines at dozens of additional locations scattered throughout the theatre. The construction statistics laid bare Japan's increasingly hopeless position. Mare Island Naval Shipyard alone produced multiple ABSD sections, while simultaneously constructing new destroyers and cruisers from the keel up. The shipyard employed 46,000 workers operating in 3 shifts around the clock, 24 hours daily. During an 18-month period, Mare Island by itself produced more total floating dry dock capacity than Japan's entire permanent dry dock infrastructure possessed. Lieutenant Commander Haruki Iki, serving as a naval architect at Yokosuka Arsenal, conducted detailed analysis of American repair capabilities during early 1944. His comprehensive report calculated that American floating dry docks positioned throughout the Pacific could simultaneously repair 18 capital ships, 36 cruisers, and over 100 destroyers at any given time. Japan's complete domestic repair capacity could handle 6 capital ships, 12 cruisers, and 40 destroyers. More critically, Iki identified what he termed the multiplication effect of forward repair operations. A ship sustaining damage at Leyte Gulf and repaired at nearby Ulithi returned to combat operations in 1 quarter the time required for a vessel making the journey to Japan. His conclusions carried stark implications. We find ourselves engaged with an adversary who transports his homeland directly to the battlefield itself. We cannot sink their ships at a rate faster than they restore them to service. The floating dry docks achieved their first truly spectacular demonstration of capability during the invasion of Kwajalein in February 1944. The battleship USS Maryland absorbed kamikaze strikes that tore a 40-foot hole through her deck armor. Traditional naval doctrine would have dispatched her to Pearl Harbor for repairs, removing her from the battle for months. Instead, Maryland steamed 240 miles to Majuro Atoll, where AFDB-2 waited in position. The massive dock, under the command of Commander Joseph J., Rochefort, a different individual from the famous intelligence officer who broke Japanese naval codes, submerged its deck structure below the surface, permitting Maryland to position herself precisely over the keel support blocks. Within 4 hours, powerful pumping systems expelled 8 million gallons of water, raising the 45,000-ton battleship completely free of the ocean. Captain Yoshitake Miwa, commanding submarine the Fro 184, observed this operation through his periscope and transmitted to Tokyo headquarters a report filled with implications. Maryland entering floating dry dock facility at Majuro. Extensive damage clearly visible to hull and superstructure. Conservative estimate minimum 3 months for adequate repairs. 3 weeks later, Maryland departed Majuro under her own power with full combat capability clearly apparent to observers. The Americans have rendered both time and distance strategically irrelevant. Commander Mochitsura Hashimoto of submarine Thur 58 later composed reflections that captured Japanese frustration perfectly. Our submarines would successfully attack an American aircraft carrier or battleship, and we would calculate the months that vessel would require for repair based on our own experience and capabilities. Then we would encounter that identical ship mere weeks later, fully operational and engaging our forces. It resembled fighting mythical creatures from ancient stories that possessed the ability to heal their wounds instantaneously. AFDB-7, maintaining operations at Leyte Gulf, demonstrated truly comprehensive overhaul capability when it handled the aircraft carrier USS Franklin following devastating kamikaze damage sustained in March 1945. The Franklin had suffered the most catastrophic damage of any American carrier that ultimately survived the war. 807 sailors had perished in the attack. Standard naval procedure would have classified Franklin as a constructive total loss not worth the resources to repair. However, the crew of AFDB-7 numbered 1,000 personnel, including specialists in virtually every aspect of ship construction and repair. They operated shift schedules that maintained work continuously without interruption. Master Chief Petty Officer William Delaney later provided testimony that illuminated the achievement. We essentially reconstructed that carrier from the interior structure outward. In a stationary yard with complete facilities available, this represented a 6-month project at minimum. We accomplished it in 11 weeks while operating in an active combat zone. Lieutenant Commander Sadao Kusaka flew reconnaissance missions over American base facilities. His April 1944 report revealed the depth of strategic shock spreading through Japanese naval command. Conducted detailed observation of Ulithi anchorage. Counted 6 large floating structures initially identified in previous reports as possible cargo vessels or supply ships. Upon closer detailed examination, these structures are actually mobile dry dock facilities. One currently contains the battleship Iowa, with her hull completely exposed for repair work. American maintenance capacity proves to be not fixed and stationary, but genuinely mobile and deployable. They transport their base infrastructure with their fleet. Admiral Soemu Toyoda, who assumed command as Commander-in-Chief of the combined fleet following Yamamoto's death, received these accumulating reports with mounting desperation. At a staff conference meeting in May 1944, he presented to his officers the mathematical reality of impending defeat. If the Americans can repair their vessels 3 times faster than our capabilities permit, we must achieve a kill ratio of 9 enemy ships for every one we lose. This represents an impossible requirement. We are not being defeated by American ships or American sailors. We are losing to American floating steel and industrial organizational capacity. Each dry dock section incorporated complete living quarters for its assigned crew, equipped with bunks, galley facilities, and medical treatment spaces. Seaman First Class Robert Leckie, assigned to AFDB-3 at Manus, later described the experience of daily life aboard these facilities. There we existed, thousands upon thousands of miles from home, living our lives on this massive steel structure floating on the ocean. We organized movie nights projected on the dock walls. We played baseball games on the dock floor when no ship occupied the facility. We weren't merely repairing damaged ships. We were a floating piece of America itself transported to the war zone. The food quality aboard floating dry docks became legendary throughout the fleet. While combat vessels subsisted on Spam and powdered eggs, the dry docks maintained frozen food storage lockers and full bakery operations. AFDB-2 served 2,000 complete turkey dinners for Thanksgiving in 1944 to crews of damaged ships undergoing repairs. Vice Admiral Takeo Kurita experienced the strategic impact directly during the Battle of Leyte Gulf in October 1944. His battle planning had assumed that damaged American ships would withdraw for repairs to distant facilities, progressively weakening the invasion force. Instead, damaged vessels simply sailed to nearby mobile repair facilities and returned within days to resume combat operations. Kurita later composed reflections on this bewildering reality. We would inflict damage on an American cruiser and reasonably assume it eliminated from combat operations for weeks or months. Then we would face that identical ship again merely 3 days later. We were not fighting simply the American fleet deployed in the Pacific. We were engaged with their entire industrial system, which they had somehow rendered portable and mobile. The most remarkable rapid repair achievement actually occurred with USS Yorktown following damage at Coral Sea and her subsequent participation at Midway. Yorktown, severely damaged during the Coral Sea engagement, arrived at Pearl Harbor on May 27, 1942. Admiral Nimitz gave repair crews 72 hours to restore combat capability. The ship entered Dry Dock No. 1 on May 28th. 1,400 workers from Pearl Harbor Naval Shipyard laboured continuously around the clock. Yorktown departed on May 30th with her flight deck patched and boilers operational, though far from fully repaired. Japanese intelligence remained convinced Yorktown was still undergoing extended repairs. When Japanese pilots at Midway reported attacking a third American carrier, Admiral Nagumo's staff refused to credit the reports as accurate. Lieutenant Joichi Tomonaga transmitted before his death a message that captured Japanese confusion. The Americans possess 3 carriers in this engagement, where our calculations indicated only 2 were operationally possible. By mid-1944, American floating dry docks had systematically transformed the Pacific Ocean into an American maintenance and logistics highway. Ships sustaining damage at Iwo Jima could be repaired at Guam. Vessels struck at Okinawa found floating dry docks waiting at Karama Reto. Commander Sadatoshi Tomioka calculated the cumulative strategic impact in stark terms. The enemy has effectively eliminated distance as a strategic factor. A ship damaged during operations off Formosa can undergo repairs at Leyte faster than we can repair a ship damaged at Leyte and return it to Sasebo. We are fighting an adversary who has rendered geography strategically irrelevant. Between 1942 and 1945, the United States produced 7 advanced base sectional docks and 31 auxiliary floating docks of various sizes. The combined lifting capacity exceeded Japan's entire permanent dry dock capacity by a factor of 4. Each ABSD cost approximately $40 million to construct and deploy to forward areas, a sum equivalent to a light cruiser. Yet the strategic return far exceeded the investment. Rear Admiral Kizo Kimura captured this reality in his personal diary. The Americans construct floating dry docks the physical size of city blocks, and then tow these structures across the Pacific Ocean as though already certain of ultimate victory. They are constructing the infrastructure of peace while we still desperately fight the war. Chief Petty Officer Marcus Thompson, serving as a hull repair specialist on AFDB-2, had undergone 18 months of intensive training at Mare Island. His team of 40 skilled welders could repair torpedo damage that would have challenged even major shore-based shipyards. We transformed ourselves into artists of destruction repair, Thompson recalled in later years. A destroyer arrives with her bow completely blown off. We would fabricate an entire new forward section in 5 days of continuous work. The medical facilities incorporated into floating dry docks added significant strategic value beyond simple ship repair. Each major dock included a hospital equipped with complete operating rooms. Dr. Lawrence Steinberg, serving as Chief Medical Officer on AFDB-1, performed over 200 major surgical procedures during his deployment. The facility treated not only personnel injured aboard the dry dock itself, but also casualties from damaged ships undergoing repairs and from combat vessels operating in the vicinity. In November 1944, submarine Y-365 received orders representing a shift in Japanese targeting priorities. Rather than attacking warships, the submarine was directed to penetrate Ulithi anchorage and attack the floating dry dock facilities themselves. The mission reflected the growing Japanese recognition that these repair facilities represented strategic assets as valuable as the warships they serviced. The submarine was detected and destroyed before reaching Ulithi, becoming one of 6 Japanese submarines lost while attempting to attack floating repair facilities. The only genuinely successful Japanese attack on floating dry docks occurred on April 22, 1945. Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at 14,000 feet altitude, achieved hits on unoccupied floating dry dock sections. A follow-up attack managed to damage Section G of ABS-D2, but the dock's own crew completed repairs to their own facility within 3 days, a demonstration of the self-sufficiency these units possessed. Commander Masataka Okumiya later analyzed these failed attempts to neutralize the dry dock facilities. We could occasionally succeed in damaging individual warships, but the floating dry docks appeared to multiply like living organisms. They were not simply floating docks for repairs. They were floating factories that could effectively reproduce themselves through their repair capabilities. The Okinawa campaign, extending from April through June 1945, witnessed the most concentrated kamikaze damage to American naval forces. Over 400 ships sustained varying degrees of damage from suicide attacks. A concentration of floating dry dock facilities at Karama Retto operated continuously throughout this period, sometimes lifting damaged ships onto their decks while still under active air attack. Captain Toshiyuki Yokoi, commanding kamikaze operations, recorded observations that revealed the futility of the attacks. Our pilots sacrificed their lives to inflict damage on American vessels, only to observe those same ships returning to combat operations within mere days. The floating dry dock facilities operating at Karama Retto repair ships faster than we can organize and launch new attack waves. Of 404 ships damaged during the Okinawa campaign, 387 were repaired sufficiently to continue operations without requiring return to permanent shore-based facilities. The destroyer, USS Lafay, struck by 6 separate kamikaze aircraft on April 16th, was operational again by May 1st. The repair speed defied Japanese understanding of what was possible. Captain Minoru Genda reviewed captured American planning documents following the war's conclusion. The documents revealed American intentions to deploy 12 major floating dry docks and 40 smaller units to Japanese home waters to support the planned invasion. Genda later reflected on the implications. Even if we had somehow managed to damage half their fleet on a daily basis, they possessed the capability to repair ships faster than we could reload our guns and organize new strikes. The mathematical impossibility of victory had been built into the situation from the beginning. Working with battle-damaged ships meant floating dry dock crews regularly handled unexploded ordnance and worked in areas contaminated with toxic smoke and chemical residues. On AFDB-3, 7 workers died when a structural bulkhead collapsed during repair operations on USS Pittsburgh, yet crew morale remained consistently high throughout deployments. The unofficial motto of AFDB-2, painted in letters 10 feet high on the dock's superstructure, proclaimed simply, "We keep them fighting." Admiral Somu Toyoda's post-war interrogation by American intelligence officers identified 3 decisive factors in Japan's ultimate defeat: American submarine warfare against merchant shipping, fast carrier task force operations, and floating dry docks. Regarding the third factor, Toyoda stated directly, "Your floating dry dock facilities killed the Japanese Navy as surely and effectively as your bombs and torpedoes accomplished. You rendered time and distance strategically irrelevant. You transported your homeland's complete industrial power directly to our home waters. Between 1943 and 1945, American floating dry docks performed 1,847 major ship repairs and 8,234 minor repairs. They successfully returned 95% of damaged vessels to operational service within 30 days. Commander Joseph Rochefort, the intelligence officer whose code-breaking contributions helped secure victory at Midway, offered insightful analysis. The Japanese believed they were fighting against our ships and our men. They were actually engaged in combat with our entire industrial system, which we had rendered portable and deployable. Every floating dry dock represented Detroit and Pittsburgh made physically manifest in steel that floated on water. The organizational vision originated with officers like Rear Admiral Ben Morrell, who understood that American industrial superiority meant nothing strategically unless that capacity could be projected directly to the point of conflict. His vision successfully transformed industrial power from a homeland advantage into a deployed weapons system as potent as any battleship or carrier. Mare Island Naval Shipyard employed 6,000 women workers by 1943. Marjorie Muller, among the first female welders hired, worked on Section F of ABSD-2. She later reflected that every perfect weld she completed meant American sailors would survive to return home. The Chicago Bridge and Iron Company employed 4,000 African-American workers at its California facility, where they constructed 3 ABSD sections while achieving production rates that exceeded some racially integrated yards. Admiral Arleigh Burke frequently cited floating dry docks as prime examples of American innovation successfully applied to warfare. The Japanese forces brought superior training and tactical excellence to engagements. We brought floating dry docks to the battlefield. They made the ocean a zone of combat. We made it a factory floor where we manufactured victory. Japanese naval attachés had filed detailed reports on American shipbuilding capacity throughout the 1930s, but they interpreted observations through the lens of their own experience and assumptions. Commander Yoshiro Fujimura visited Chicago Bridge and Iron facilities and observed sectional construction techniques. His report noted that Americans constructed industrial plants like children's toys in prefabricated sections designed for assembly. He concluded this approach was interesting, but fundamentally irrelevant to naval construction requirements. As the war reached its conclusion, American floating dry docks were still being produced in large numbers. AFDB Units 8 through 14 remained under construction for the invasion of the Japanese home islands that ultimately never occurred. The conflict ended before they could be deployed and utilized. The historical narrative of American floating dry docks represents the collision of fundamentally different concepts of military power. Japan conceived power in traditional terms: warrior spirit, tactical excellence, superior training and discipline. America conceived power in industrial terms: production capacity, repair capability, logistical sustainability, and the ability to project industrial power across oceans. The Pacific War tested these competing visions against each other in the most comprehensive manner possible. Once American floating dry docks had been deployed systematically across the Pacific theater of operations, each individual unit represented the entire American industrial system rendered mobile and deployable. They were the assembly lines of Detroit and the steel mills of Pittsburgh transported directly to the battle zone. Against such concentrated industrial might made portable, no quantity of traditional military excellence could ultimately prevail. Admiral Soemu Toyoda's final assessment of the war captured their ultimate significance with clarity. You defeated us strategically at the moment your floating dry dock facilities arrived and began operations in the Pacific theater. We could sink your ships, but you possessed the capability to raise them from the ocean floor, repair them, and return them to service. The dry docks meant you could absorb any level of losses and continue fighting effectively. The Pacific Ocean itself had become an American lake, not because you controlled every square mile of its surface, but because you could maintain your control anywhere and at any time through your mobile industrial infrastructure. We came to realize we were not fighting simply against ships and aircraft and men. We were fighting against the entire industrial capacity of the United States, and that was a war we could never win.